Joachim Frank was born in Germany in 1940.
These were very tumultuous times. When I was 4 years old, I saw a neighbor's house burn down, and we had to go to another place in a courthouse 20 miles away. And this courthouse had a basement which was used for shelter. All the different people came in with little children crying and listening to the sounds of planes. Many years afterwards, into my teenage time, I had nightmares that brought me right back into that basement. And I think it instilled some kind of a need to restore order.
He found order through science. After completing his PhD in physics in Germany in 1970, he got a prestigious Harkness Fellowship to work in the U.S. In 1975, he joined the faculty at the Wadsworth Center in Albany. At the time, computerized image processing was a new technique that promised to sharpen details of blurry images. Stack enough images of identical objects and you can get the computer to average out noise. But how do you get identical images from photos taken by an electron microscope?
We could think of the specimen preparation as throwing molecules like dice so that they land in random orientations. If you want to average only those that are alike, then we need to have some kind of a sorting.
In 1980, everyone at the Wadsworth Center shared a single computer. One day, Frank happened to be in the computer center.
I saw a printout coming up. There were clusters of figures.
The printout belonged to a clinical medicine specialist who was analyzing blood samples.
I look at this printout and I call over to my student and say, "Stop what you're doing, our problem is solved." Images are patients and pixels are blood samples. And that's all we needed to do. In the rest of the afternoon, we simply put an interface together.
They called the image sorting program and user interface Spider. Using dozens, then hundreds, and now many thousands of images of individual molecules, Spider reconstructs details that are otherwise impossible to see. Then a scientist showed him some electron micrographs at a conference. Could Frank do anything with them? They were ribosomes, key to life as we know it. All living cells, animal, plant, and bacteria, need them to synthesize proteins. They are important targets for antibiotics. Frank got 81 images, which he fed into Spider. The program generated beautifully detailed images. It was a major breakthrough. Frank spent the next 3 decades studying the ribosome in ever finer detail. He coupled image processing with a new technique, crioelectron microscopy, to study molecules in their native state in water, rather than the artificially stained samples used before. By 1998, the resolution was so good that
we were able to show that the ribosome changed its conformation in a major way, that the 2 subunits essentially formed some kind of a ratchet-like motion.
With so much structural detail, scientists have a deeper understanding of how ribosomes build proteins. Researchers are designing new antibiotics to interfere with specific actions of ribosomes. In 2008, Frank moved his lab to Columbia University. Beyond the lab, Frank is a published poet, author, and photographer. His science knowledge adds to his artistic appreciation of the world. For example, once driving through a woods,
this idea occurred to me that in every cell of every leaf of every tree, there are ribosomes doing this thing. And it made me realize that I'm the only one who has this epiphany right now, because nobody drives around with this kind of appreciation.
The 2014 Benjamin Franklin Medal in Life Science is presented to Joachim Frank.